Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fatihah Ashikin binti Muhammad Shukri. I'm from Beta Mechatronics. Okay, today I will present for mini project Electric Machine Fundamental EMF with the topic or title as DC Motor Control. Okay, so here for mini project, we are given 4 questions or tasks, which are the first one is we need to create on the DC permanent magnet motor Simulink block in library. The second question is introduction to the control design and linear analysis. The third one is introduction to the control design and compensation design. And the fourth one is the PID controller. Okay, for question number 1, which is the creation on the DC permanent magnet motor Simulink block in library. Okay, this is the simulation model that I got, that we are asked to do. So the next step is Simulink translation of the model, where we need to draw this kind of circuit in MATLAB Simulink. So for the second step, okay, this is the circuit that I have uploaded in the Simulink. Okay, and I have saved it in the name of DC PM Moto. This DC PM Moto. Okay, the next step is I need to create a function block with its function block parameters window. So first step after that is for the question for the step 1.3, I need to highlight all the components and creating a subsystem. And so here for step 1.3, I have done all the creating subsystem and delete all the components. And I also have done with the mask subsystem, which is I have include all the parameters in the mask editor. Okay, this is the 4 parameters, which are the armature resistance RA, armature inductance LA, torque constant KE, and also friction viscous gain. Okay, this is for question this is for step 1.3 for creating a function block. Next step is testing the function block according to the details given. So here I need to put the constant, the 3 constant at J, TL and U, and then I need to put the scope name as TE, W and LA. So from question 1.3, we need to draw the constant and also scope. So first, put up the constant here and copy the constant, 3 constant over here. So paste the constant and put it over here. Next, move on to the scope, drag it out here and paste two scope for LA and W. Okay, so connect to the DC PM motor Simulink. And follow the details given in the step 1.4, 0.05, 400. First one is First one we name as DEWLA. So after we have following all the details given, we need to adjust here to 1 second, the stop and the stop time. 1 second. So then we also need to edit the subsystem mask parameters, which is 0.5, 0.01, 0.5 and 0.01 for each parameters that we have assigned earlier. Then we're running our circuit to test it. So for TE, I got this kind of graph, which is the same as at the first picture. For W, I got this kind of graph, same as the third picture in the question. And for LA graph, I got the same as in the second picture in the question given. Okay, that's for question number 1. Move on to the second question, which is introduction to the control design and linear analysis. So the first step is we open the loop model. So this is the given loop model that I will created or plotted. So I've been plotted the model earlier. So this is the model that I have been plotted. Okay, next, adjust the JTL and U and try to running and get the graph that have been given in the question. So the details I need to change a bit over here. 5, because the question, the details are given 5, and then we'll try to running the step. So for the first step, I got the W graph. Same as in the question given. And for LA graph, I got like this, and this is the same as the picture given or graph given in the question. Move on to the next step is introducing the input and output of the system to characterize the function. So next, what I should do is I need to click the line and choose linear analysis point and input perturbation. So the next one is I need to choose the linear analysis point, but the output measurement. So this is the step. This is the next step for question number 2. So next, I need to set up all the selecting the linear analysis and also selecting the type of result. And I have been select the type of result before. The last but not least is plotting the result. So for question 2, question J 0.05. Adjust J to 0.05 only. Okay. Open at the apps and click model linearizer. So after that, we need to click step add linear analysis tools, and we are waiting for the result, the graph of result. So this is the step response graph that we got for question for step 2.5 when we assign the J value to 0.05. Next, we will plot the bot graph, the bot plot. And this is the bot plot graph that we got for J 0.05, and it is the same like in the question. Okay, next we have been asked to change the value of J from 0.05 to 0.005. So here we need to change the value of J to 0.00, and then we will click the model linearizer and select the step item in linear analysis tools. So the estimated result that I should got is like this, and the result that I got for step response is the same as the estimated result. So next I will click the bot plot graph to view the bot graph for the value. So this is the estimated graph for J when J is equals to 0.005. So the bot plot graph that I got is the same as in the question also. When the J is 0.005. Okay. So there is the steps for question number 2. The third question is introduction to the control design and compensation design. Okay, this is the circuit that I need to draw, and I have already draw the circuit before. Okay, this is the circuit that I've been drawing in Simulink. So we need, the next step is selecting the compensation design, and I have been also select the compensation design. Next, I have also checking the input and output of the closed loop. So next we move on to selecting the blocks which will be tuned during compensation design. So here, okay, so here we will move to the apps. We choose the control system designer. Okay, next we need to add blocks and click gain. Then click OK, edit architecture. Okay, next we need to select the Simulink block tunable parameters for it to able to appear the graph like this. Okay, so choose turning method. Choose for the specified input signals, we choose closed loop ref1, and for output signal we choose closed loop DC PM motor Simulink, and then we plot it. Okay, this is the board editor, which is the board graph for question number 3, and it is the same as the compensation design or the graph that have been given in the question. It is the same. Okay, next we plot the new step. So for new step graph, so this is the graph that I got, and it is the same also like the graph that I should get in the question for question number 3. And the last but not least is the fourth question, which is PID controller. Okay, for PID controller, I have plotted this kind of circuit for simulation. So this is the PID controller that I have plotted. So for question number 4, we just need to run the circuit. So just running the circuit. If we set up the input value at J, TL and U with J as 0.05 and TL as 4 and U with the PID controller as WREF 200, so the result that I got is like this for W, and LA is looking like this for LA. But if I change the value from 4 to 5 and 200 to 100, So when I'm running the circuit, the graph that I will get will be looking like this. Slightly different from previous value of input. Okay, that's all for question 4. Okay, as for conclusion, Simulink in MATLAB is used to plot and do the simulation on DC motor control. The discussion has made in this paper about the field-controlled DC motor in MATLAB simulation environment. The results are shown graphically and the calculation is done for a model with speed, torque and load in MATLAB to illustrate the methodology. The validation of models are done with the state space model built in Simulink. This validation is done to ensure that model can be used to replicate the behavior of a DC motor control. Results obtained are then compared and found to be in close agreement. The contribution of this work is significantly expedient in the field of automobile, mechatronics and control system and educative for hand-on laboratory. It also provides a novel approach to simulate the control system in a concise and precise method. That's all from me for mini project electric machine fundamental for DC motor control. Thank you.